Another video on parabolas, but this time we're going to be talking about parabolas with a focus and a directrix. So before we get into detail of how to graph parabolas with a focus and a directrix, let's talk about what they are. So we already know what a parabola is by now. A parabola is a curved graph because all the x values are going to be squared. All parabolas have a vertex. That is when it changes from increasing to decreasing or decreasing to increasing depending on which direction this opens. And of course, we have an axis of symmetry. That's the green line here. Axis of symmetry cuts a parabola in half symmetrically. Now, the two new things that you're going to learn in this video is that we have a focus, which is a point that's inside of a parabola. And we have another line called a directrix. And this is a line that is outside of the parabola and will always be perpendicular to the axis of symmetry. Now, any point that is on a parabola will always be equidistant from the focus and the directrix. So we have a few examples here. This orange point is equidistant from here, the directrix, and your focus, even if you get closer. And the other thing is the vertex is also equidistant from the focus and the directrix. So all points on a parabola will always be equidistant from a focus and a directrix, okay? And that includes the vertex. So now that you know a little bit about what the different parts of a parabola are, we're going to go graph some. Now, for the purpose of this video, we are going to sketch graphs. So we're going to talk about two new types of an equation. Now, they look almost identical, except for the fact that now we can square the y values. So you might have a parabola that opens up or down, like you've already been experienced, or left and right now. So how do you know? Well, if we have the x being squared, then it's going to be your traditional parabola that you've done for years now, where it's going to open up or down. But if we have x is equal to a y squared, that's going to change this parabola to opening to the right or to the left. Okay? Now they do have some similarities. The vertex is still going to be h comma k just like it was back in the day. Our axis of symmetry, if it opens up or down, it's still x equals the h coordinate or your x coordinate of the vertex. But if you're going to go sideways, remember, we have to split a parabola in half with an axis of symmetry. So if we have one opening to the left, to cut it in half, we need to split it like that. So that's going to be a y equals equation. So that's going to be y equals the k value of your vertex. And then the focus and directrix. There are some formulas here of how to find it. But when it comes to graphing a focus and a directrix, I find that it's much easier to just use a little bit of common sense with the graph. So you'll have those formulas if you want to use them. But we're just going to jump into graphing these, and it's going to be much easier to do it just by thinking about the location. Okay, and then of course we had 4p, which we're going to use. So we're going to talk about some of these first. Now the first thing you want to do for this is determine if it's going to open up, down, left, or right. So if we have a positive value for our p, and if we have an x squared, as this set up here, positive p values will make it open up if x is squared. So this is a positive value, x is squared, this graph is going to open up. So the first thing we're going to do is plot our vertex. Since there's nothing after the y or the x, the vertex is going to be at the origin. Both of these that we're starting with are going to have a vertex at the origin. And we're just going to sketch a parabola. So we're just going to sketch a parabola that opens up. And this is going to make graphing the other important information easier. So we know we have our vertex at 0, 0. So it even works with the axis of symmetry. So our axis of symmetry must split the parabola in half. So if we were going to cut that parabola in half, we would draw a vertical line right through the vertex. So our axis of symmetry is going to be x equals 0, because that's a vertical line that passes through the coordinate x equals 0. So now the two new points. The first thing we have to do is find our p-value. So to do that, we're going to set this number equal to 4p. So 4p is equal to 8. So p is equal to 2. Now that was in the formulas up here. We have 4p in front of the parentheses, 4p over here. So it's not going to say 4 times 2. It's just going to say 8. So it's going to be your job to set this number equal to 4p and find out that the p-value is 2. Now, like I said, there are formulas, but 2 is the distance away from the vertex. So I mentioned to you that the focus is always inside of a parabola. So you go stand on the vertex and you just go 2 points above it. And look, you can just state it. The focus is at 0, 2, because you are 2 above. Now, like I said, if you want to use the formula, that's fine. I did tell you that it was h, k plus p. So if your vertex is h, k, then it's still h, which is 0, and then k plus p, which would be 0 plus 2. But again, memorizing formulas is sometimes more complicated than it needs to be. So if you think about the term that p is just your distance from the vertex, then your focus is 2 above because it must be inside. The other thing I also told you is that the directrix is always outside of the parabola and will never touch the parabola. So at same distance is 2 units away from the vertex outside, so it's 2 units below it. So your directrix would be at y equals -2. Or, as I mentioned, y is equal to k value, which is 0, minus the p value, which is 2. So y is equal to 0 minus 2, so y is equal to -2. So whichever way you want to do is fine with me, okay? So I'm going to step through one more with you from the beginning to the end. Again, I warned you that the beginning, or the first two, we were just going to focus with a vertex at the origin. So our vertex is at 0, 0 again. And we're going to give it a little sketch. Now, notice what happened this time. This time, x is equal to the y values squared. So when we have a y squared, that's positive. This is going to open to the right. So here we go. We're just going to sketch just a generic graph of a parabola opening to the right. And now we're going to go have fun with the other stuff. Now this time the axis of symmetry is going to be a little bit different. The axis of symmetry must cut the parabola in half. So if we were going to split this parabola in half, you would have to draw a horizontal line. And you can see that that's at y equals 0. And then we need to talk about our focus and our directrix. The focus and the directrix are going to be the same distance away from the vertex. So we have to go find that distance. The distance is 4p is equal to the 16 that's out front. Divide both sides by 4, so your p value is 4. So that means the focus is 4 units on the inside, and the directrix is 4 units on the outside. So your focus is 1, 2, 3, 4 inside the parabola. So that would be at 4, 0. And your directrix is 1, 2, 3, 4 to the outside. And it has to be a line perpendicular to your axis of symmetry. So a vertical line is at x equals, and then the x value is -4. Okay, So that's how you graph parabolas that now can open up, down, left, or right using a focus and a directrix. So there's two more examples here. But this time, the vertex has shifted. So I'm going to step through this one with you, and then you're going to try the last one on your own, and we are done with this video. So the first thing I'm going to do is just start laying out some of my work. The 4p is equal to a -4. So our p value is -1. Now I don't want you to think about -1 in terms of a distance. It's just the distance is going to be 1. So I told you, you can use the formula. So if you want to use the formula, you need the -1. But if you just want to think in terms of just mapping it out and using a little bit of common sense with the graphing, then you just think of distance as 1, not a -1. So we need to plot our vertex. Our vertex is opposite of x, so that's a +3, comma, opposite of inside of the y, so that's a -2. So our vertex is at 3, -2. Since x is squared, it's up or down. Since it's negative, it's going to open down. So I'm just going to sketch a parabola that opens down. And now we're going to go find the other fun stuff. Our axis of symmetry must cut this parabola in half. So we would cut it in half right there, where x is equal to 3. Just as I mentioned. See, x coordinate is 3. That's when it opens up and down. If it opens left and right, we follow the y coordinate. Our focus is always inside. Now the distance away from the vertex is 1. So we would have to go 1 unit inside of this parabola. And if our focus is 1 inside, that's below. So that means this became 3, -3. And finally, our directrix is always outside. Same distance away, so the distance is 1. So we would have to draw a perpendicular line to the axis of symmetry, which means it's a horizontal line at y equals. Now it's 1 above the focus. So that's where the y values will always be -1. Okay? So again, it's a different style of a parabola function, so it takes a little getting used to, but I would like you to pause the video and see if you can handle this next one on your own. As soon as you're ready, click play and we'll see if you got it. So here we go. Last one, the vertex is at opposite of the inside for the x, opposite of the inside for the y. So it's at -4, comma, +1. So we're going to -4, +1. Y is squared this time, and it's negative. So when y is squared and it's negative, it's going to open to the left. p is equal to the number out front, which is a -12. So p is equal to a -3, but our distance is 3 units. So to go find our axis of symmetry, it is always going to split the parabola in half. A horizontal line is y equals the y coordinate, which is 1. Again, if it opens left and right, it's y equals the k value. And then we have our focus, which is inside, a distance of 3 units to the inside of the parabola. You can just look at that coordinate. It's -7, comma, 1. Or, if you were to use the formula, the p value is a -3, and it is h plus p. So h is -4 plus a -3 takes you to -7. So the formula still works if you like to use it. And finally, your directrix is going to be a perpendicular line, so it will be a vertical line. So x equals 3 units to the outside of your vertex will put you over here. So that would be x equals a -1. Again, the formula still works. Because if the formula is going to tell you that it's the h value minus p, Negative 4 minus a negative 3 is going to give you plus 3, which is still going to give you negative 1. Okay? So again, I know it's a little bit different. It's a little challenging. We'll have plenty of time in class to do more examples. But those are the basics of a parabola. This is Longo, and I'm out. See you, bye.